Hello! In this lecture, we will talk about connected graph. Let's start. Connected graph, it's a graph in which every two vertices are connected by a path. If there are some vertices in the graph, they are connected in such a way that there is always a possibility to find a path between two vertices. For example, I can choose this vertex and this vertex, and it will be always a possibility to find such edges to traverse from one vertex to another. Is this a connected graph? No. Why? Because when I will choose vertex A and vertex D, there is no possibility to traverse from A to D. So this graph isn't connected. And here, is this graph connected? For example, from E, I want to go to G. Is there a possibility? Yes, I can go this way. And maybe one more example, from A to F. So let's try this way and this way. And if we spend some time and choose any two vertices and try to find a path between them, there will be always possible. So this graph is connected. Is every connected graph a simple graph? Let's check. To be a simple graph, we need to satisfy two requirements. So first requirement, no multiple edges. And second requirement, no loops. So let's draw connected graph. For example, like this. Is this graph connected? Yes. We can traverse between any two vertices in this graph. And is this graph simple? Yes. There are no loops and no multiple edges. If there is an edge between two vertices, it's the only one. So the idea is to add something to this graph to save connectivity, but to destroy the property of being simple graph. How to do it? For example, we can draw a loop. Or we can draw an additional edge here. Drawing additional edges doesn't disturb the connectivity of the graph, because we get another option to traverse in this graph. But we destroy the requirements for being a simple graph. So is every connected graph a simple graph? No. And that's the example. So it's a graph with a lot of edges. So we have connectivity, but there are some loops, for example, or multiple edges. Vertices of a graph are adjacent if there is an edge connecting them. We say that vertices A and B are incident with this edge. Similarly, two edges are adjacent if they have a common vertex. Okay, so vertices are adjacent if there is an edge connecting them. So vertex A here, vertex B here, there is an edge connecting them, so we can say that A and B are adjacent. We say that vertices A and B are incident with this edge. So let's assume that here is the edge E1 E1 is incident with A, and also E1 is incident with B. Similarly, two edges are adjacent if they have a common vertex. So for example, somewhere here is vertex C, there is an edge E2, and we can say that E1 and E2 are adjacent because they have a common vertex, vertex B. Is it true? A and C are adjacent. A and C. Yes, because there is an edge E1 that connects them. So, yes, that's true. B and D are adjacent. No, there isn't any edge that connects B and D. So, it's not true. B and C are not adjacent. B and C. They are adjacent because there is an edge E2 that connects B and C. So it's also not true. C and D are incident to E3. C and D are incident to E3. Yes. A and C are incident to E2. A and C are incident to E1, not E2. So this is also false. E1 and E3 are adjacent. E1 and E3 are adjacent because they have a common vertex C. So that's true. E2 and E1 are adjacent. Yes, they have a common vertex C. Okay, that's all I've prepared. Take the quiz and see you in the next lecture.